I was appointed professor at UBC in 2006, and when I went there, green roofs was sort of quite trendy, I would say. But at the time, green roofs was nothing new in Europe. They already were standard. When I came to Vancouver, that I noticed that a lot of the green roofs who were designed there were fed with drinking water to keep them alive in summer. And for me, from Germany, I was sort of used to use green roof as a sustainability tool. So that didn't really fit the bill. And the lab then was established by Jon Laurenz, a former master's student, research student at the time, now he's an architect in Spain, and Kevin Kong, also a former research student who is now an architect here in Vancouver. We all noticed that in the research on stormwater, which we were interested in to capture the water better, there was something missing. And that was the evapotranspiration rate, what we call the ET in the calculations of the existing formulas. So we developed and extended the formulas to include the evapotranspiration rates of the soil and the plants on green roofs. I have two projects I worked on which had a big impact on my research. And the first one was called Sapporo High-Speed Railway Project in Japan when I was working for Taisei Corporation. And I worked with a colleague of mine who had just graduated from the AA, a Japanese architect, and we designed together a high-speed railway station which had a huge green roof on top in Japan, in Sapporo. And when the building was planned, he asked me to design a park on it. And that inspired me to learn more about green roofs. In 1995, I was hired by Krüger and Mörle, a Stuttgart-based firm in Germany, which was quite renowned in the 80s and had a lot of projects. They won the contract to do work with Renzo Piano, who was the master planner on the what was then called the Daimler Chrysler area at the Potsdamer Platz, basically a site with 17 buildings. And I was chosen as the project landscape architect because I was the only one who was fluent in English and who had an international experience. And it was also the first project where we really used LID. So we used the water from the roofs to irrigate the gardens of the intensive roof areas in the courtyards, which were also specific, or green roofs really also used the water for toilet flushing. And we also used the water and collected it and cleansed it to drinking water quality to use for the artificial lake, which was created by Renzo Piano. I think what I noticed after tenure, that what I really noticed is the LID. The problem wasn't the technology and the research, it was to get the general public enticed. So I started drawing and visualizing LID. Since it was on the roof, many people didn't see what I was doing. And so I developed with the iPad at the time, the animation happened. And so with my animated hand drawings, I started visualizing and also trained a new generation of researchers, Jericho Bankston and Feng Wu, to develop a LID calculator, which is an application to calculate LID in the new design for an urban space.
As designers, we see through visualization. It helps us understand problems and communicate to those who may not understand. At Greenskins Lab, we believe a key tool is learning through drawing. It can help us visualize the scale of a problem in areas of challenge and focus, as well as the methods with which it can be resolved. One such thing we believe is helpful to visualize through drawing is holistic stormwater management. Greenskins Lab focuses on low-impact development systems as a key component to site design and development for stormwater management. Part of LID is utilizing holistic design and creating treatment trains such as green roofs, bioswales, retention-detention ponds, and rain gardens. By visualizing the flow of water through these systems, we can understand the benefit each system has to offer, understand how water systems can be managed through the entire site, and how without these systems, water can be allowed to drain directly into traditional stormwater management systems such as pipes, lakes, rivers, and oceans. It is important to visualize stormwater management early in the site development and building design process. It is often thought of too late and can become ill-sized, too large, too small, or requiring water to irrigate, also leading to urban and local flooding issues. Implemented too late in the design process, it often cannot achieve the maximum benefits LID has to offer. That's why we have developed a tool at the lab to address the need for LID design early in the site development process.
We have created a LID application to make the runoff calculation process much easier and friendly for everyone in the initial design phase. In the LID application, after inputting the basic climate data, you need to enter the site data to get multiple sets of results for monthly and annually runoff. The results are instantly available as the site data change. Other relevant results are also given for reference, such as the mitigation percentage of runoff and potential irrigation volume for green roofs. Based on the calculated result, users can try and adjust different LID strategies to achieve their stormwater management goals. Traditionally, for a large site, urban planners come first, take over, and do the zoning for the whole site, and then street, road, park, residential, commercial, and industrial areas are defined on a big map. Then architects come and join in to design the building for a specific site. Towards the end, landscape architects design the landscape area to fit LID in wherever possible. What often happens is that there is not enough space left over for adequate LID. With the LID application, urban planners could define different LID areas and stormwater management goals. In this way, LID strategies, site conditions, and various site use can be considered as a whole in the initial phase. For a specific site, using the LID application, architects and landscape architects can work together to optimize the LID strategy and design a solution that meets the stormwater management needs and project goals. Ideally, with the support of LID application, the urban planner, architect, and landscape architect would work together in the initial design phase to create a holistic strategy and planning outcome. So, all elements can be brought together to form an integrated community and stormwater management plan. With this application, LID could become a strong driver for an environmental friendly project.
This is a live European project called Good Local Adapt that we were implementing in Legazpi, the new green urban solutions. We were combining a design of integrating new pedestrian areas with new urban green urban solutions, such as bioretention areas with trees and greenery. Also, all of the new pavement was permeable pavement. It was also interesting the geological study of the soil, of the terrain, because it was determined that the terrain was quite impermeable. It was all mainly clay. After the permeable pavements that we were proposing, we decided to collect all this rainwater and guide it to a rainwater tank. So the town could reuse this rainwater mainly to clean the streets of the town. And also the design included a new, what we call green pergola or green canopy made out of wood, which also includes a new green roof and green wall system, which is a system of moss roof and moss wall that we are testing because this was built very recently, 2 weeks ago. So now we want to see how it works. And yeah, I think we always try to apply and implement the knowledge that the greenskins lab is making through the research. So how this knowledge could be implemented in real professional projects, in this case in the Basque Country.